All right, hey everybody, welcome back. We're going to continue with notes 8.1. We're going to continue solving systems of equations. This time we're not going to use the technique of substitution, we're going to use the technique of solving by graphing. So if you're going to use your graphing calculator, we've got to take all these equations and solve them for y equals to get them calculator ready. Then we're just going to insert the equations into the calculator and set an appropriate window that will allow us to do second calc, option 5, and find the intersections. All right, let's take a look at number 1. We can see real quickly that these are both linear equations, so we're going to have two lines. All right, and likely they're going to intersect in one point, and we'll have one solution. Although it is possible that two lines could be parallel and there could be no point of intersection. It's also possible that two lines could be graphed as the same line. They represent the same line, which means that you have an infinite number of solutions. And we're going to explore those ideas in the next section. But for right now, let's do some work, algebraic work, to get these equations calculator ready. All right, so I'm just going to work down here, pulling each of these equations down here so I can solve for y. So starting with the top equation, let's isolate y. So we're going to have 8y. I'm going to subtract the 7x. So it's 8y equals negative 7x plus 24. And the last thing we need to do is divide both sides by 8. And in doing so, we'll get y equals, and just build a fraction. So we're going to make use of that fraction template in y1 and insert this equation in there. Okay, let's go to the bottom equation, solving it also for y. So the y term is currently negative, so I'm going to actually add 8y to both sides. And then I need to then get this 8 over to the left side by subtracting it. So what happens is I'm going to make two quick moves. I'm going to subtract 8, but add the negative 8y, or 8y to the other side. Last thing we need to do is divide both sides by 8. So we'll have y here. Y equals x minus 8 all over 8. So this will go in as y2. We'll set a good window, probably zoom 6. Do second calc, option 5 for the intersection. All right, that solution on your calculator is going to be 4 negative 1/2. You can confirm it if you want to, or just kind of go with it. All right, let's continue solving this system by graphing. So we have to solve both equations for y. I'm wondering if you recognize this top equation. When graphed, it should be a circle. It's a circle centered at the origin with a radius of the square root of 169, which is 13. All right, let's get y by itself so I can get this equation calculator ready. So y squared equals, subtract the x squared to the right side. All right, let's bring in the square root. This will not simplify. This does not simplify. We can only simplify and pull out pull out an x and a 13 if we're multiplying. And even then, the negative kind of presents an issue too. But this is as simple as this side of the equation is going to be able to be simplified. All right, the square root of y squared comes out as the absolute value of y. Remove the absolute value, and you're going to have positive negative up front of the radical. So what this means is that you're going to have two equations as a result of this circle. You need to graph the top half of the circle by graphing in y1 the positive root, and to get the bottom part of the circle in quadrants 3 and 4 where the y's are negative, in y2 you're going to have negative and then this radical. Looks like I'm going to run out of room, so I'm going to come over here and solve the bottom equation for y. The y term is currently negative, so I'm going to add it to the right side, and then I'm going to subtract a 104 to the left side. Divide both sides by 8. So in y3, you'll enter this fraction. So at this point, excuse me, at this point, I want to save this calculator work to do together the next time we meet. So I'm not going to present you with the solution. I want us to find it together because of this situation right here where we have to enter two equations for this circle to produce the circle. So let's just kind of put this on hold, and next we meet, we will find the solutions. And also just keep in mind that for this circle right here, it's possible that this circle wouldn't intersect this parabola. It depends upon the placement on the grid, but we'll see that tomorrow. All right, let's look at number 3. Okay, we're going to solve by graphing. Let's get both these equations calculator ready. Starting with the top equation, isolating y. I'm going to add a y squared to the right side, but I'm going to add a 1 to the left side. We're going to bring in a square root on both sides of the equation. Bring out the absolute value of y. Remove the absolute value by adjusting and putting the positive negative up front. So just like as in the previous example, you're going to have to graph y1, the positive root, and y2, the negative root. We'll save this work to do together the next time we meet. Looks like I'm running out of room. Let's take the bottom equation, get it calculator ready. So I'm going to add the y to the right side, subtract the 5 to the left side. These equations are calculator ready. We'll do this work together tomorrow on the calculator or the next day. All right. So we'll record our solutions when we do it together. All right, problem number 4, again, is another circle centered at the origin with a radius of the square root of 8. So it's going to be the same situation as problem number 2. And we'll see tomorrow with the calculator help if this circle intersects this parabola. And if so, what are those solutions? In the meantime, let's just get the equations calculator ready. All right, the bottom equation is calculator ready. It's good to go. There's my little check mark there. Oop. Again, we'll find the solutions together. All right, let's look at an application problem of a system of equations. All right, take a few minutes and just read through this problem. All we have to do is insert these equations into y equals. So you might want to consider this as being your y1 and this equation being your y2. All right, graph y1, y2, set an appropriate window. It's going to take you a while. So I'm going to go ahead and give you a hint. I'm going to give you the window. You set your window to this setting, and find the intersection point, and we'll confirm it next time we see each other. All right, so along your x-axis, x represents the units that we're going to sell. So you might want to start with an x min of 0. So let x min be 0. And through some trial and error, my x max was 5,000. My scale, good rule of thumb, is about 1/10. You can count by 500s, you can count by 1,000. I wouldn't count by ones from 0 to 5,000. I usually try and do the tenths rule of thumb. All right, y represents my cost, so I wouldn't want to have a negative cost, so I'm going to start out with 0. And I went as high as 15,000. I needed to surpass that number right there, that y-intercept. So that's why I went past 10,000. And a good rule of thumb is 10% for your scale. 10% means drop a 0, which is 1,500. All right, so you guys pause the video, set the window, find the intersection, and we'll confirm it together tomorrow. Okay, our last example. We're going to find the dimensions of the rectangle meeting the specified conditions. So dimensions means we need to find the length and the width. All right, well, what's going to allow us to find the length and width of a rectangle? Well, knowing that the perimeter is 30 meters. So I'm going to come over here and draw an illustration of my rectangle. All right, so my perimeter is 30 meters. The perimeter is 30, and the length is 3 meters greater than the width. So the length equals 3 more than the width. So I'm going to go ahead and label my width here and here with W. So the top and bottom of the rectangle would be my lengths, both labeled with 3 plus W. All right, and then over here, we know the perimeter means to add all 4 sides of the rectangle together. So I'm going to add my 2 widths, and then I'm going to add my 2 lengths. And the sum of those 4 sides has to equal 30. So cleaning this up, we're going to have 4 W's collected, plus 6 equals 30, and let's solve this equation. Now that I know that the width is 6, I can come over here and to find the length, I'm just going to take and add 3 to my 6. All right, putting this all together, let's just report that the dimensions, which that's the question, the dimensions are 6 meters by 9 meters. You could check that answer. Double the 6, double the 9, 12 and 18, the sum of 12 and 18 give 30. All right, so that's going to wrap up solving systems of equations by the substitution method and also by graphing, and also looking at a couple of application problems involving this content.